When we have a really complex redox reaction, when we're trying to balance them, the first thing to do is label all the oxidation numbers on each compound. Okay, so we're going to do +1. We know potassium permanganate is -1, and oxygen is always -2. So manganese here is going to be +7. Okay. This one is going to be +7, and then this one here is +1, -1, and sulfuric acid H1 is +1, oxygen is -2, and sulfur, using the sum of the compound equals to 0, sulfur is going to be +6, okay, and just go through the rest. Any element's oxidation number always stays 0, and here is +1, and then we know sulfate is always SO4 2-, right? Here is -2, sulfate here is +6, and here sulfate here we know it's going to be the same, so +6 -2, and sulfate is going to be the same, +6 -2. Okay, water always +1 -2, and manganese here is going to be +2, and the last one, sodium here, is going to be +1. Okay, so the first thing is just balance all the oxidation numbers, and yeah, so when we finish labeling all the oxidation numbers, you're only going to pick the one oxidation number is changing. Okay, so we can clearly see Mn oxidation number is changing, and here Mn oxidation number is changing. Okay, so Mn is only one oxidation number is decreasing. Okay, so here we have Mn +7 to Mn +2. Okay, so that's all we need. Okay, that's all we need. So that's just the Mn, and then we're going to look at if anything here oxidation number is decreasing, that's our reduction reaction. Okay, that's our reduction reaction, and let's have a look at the oxidation reaction. Okay, so we can clearly see the chlorine. Okay, so we can clearly see the chlorine is go from minus to 0. Okay, so chlorine goes from -1 to 0. That's the only one oxidation number is increasing. That's our oxidation reaction. Okay, oxidation reaction. Yeah. So we'll just balance them first. Okay, yeah. So the so here it's you can see we transferred 5 electrons, and here you need to balance elements. Okay, so there are 2 chlorines, and then here is also 2. Yeah, so here so we can clearly see oxidation number increasing. We've lost we lost 2 moles of electron. Lost 2 moles of electron, and then here, yeah, oxidation number is decreasing. We've gained 5 moles of electron. Okay. We've gained 5 moles of electron, and then yeah, we need to make sure the number of electron lost equals number of electron gained. So we put 2 on top of manganese, and then we put 5 on top of chlorine. Okay, so here's 5, but these 2, yeah, multiplied by 5, the overall coefficient just become 10. Yeah. So yeah, our overall reaction start with 2 Mn7 plus 10 Cl minus goes to 2 Mn2 plus 5 Cl2. Okay, so that's the basis. Okay, yeah. Once you have this basis, and then you're going to add stuff back in. Okay, yeah. Where do we have permanganate? Yeah. So when we have manganese 7 plus, this is from KMnO4. Okay, so we know the coefficient in front of KMnO4 is going to become 2. Okay, and then the coefficient in front of Cl minus comes from NaCl, so the coefficient of NaCl is going to become 10. Okay, yeah. And then where does Mn2 plus come from? Have a look at here. Mn2 plus from manganese sulfate. So we're going to replace this with manganese sulfate. Okay, yeah. So we just replace all the ions with the compound. Okay, so let's write it again. So it's 2 KMnO4 plus 10 NaCl goes to 2 MnSO4 plus 5 Cl2. Okay, plus 5 Cl2. So now let's start to do the balancing. Okay, start compound by compound. So here we have 2 moles of potassium. On the other side, we have no potassium. Okay, on the other side, there's no potassium. And then the only potassium compound product we have is potassium sulfate. Okay, it's K2SO4. So let's copy K2SO4 over. We want to make sure potassium is balanced, so here's 2. We only need 1 mole of potassium to completely balance that. Okay, so potassium here is fully balanced. Okay, potassium here is fully balanced. And then now, oxygen, we're going to leave it there because oxygen has water, so we're going to deal with that in the end. And then now let's quickly have a look at sodium. Okay, so we have 10 moles of sodium. Okay, we have 10 moles of sodium. And the only compound containing sodium on the right-hand side is sodium sulfate. Okay, so let's add sodium sulfate. So also going to add sodium sulfate. So here's 10 mole. Each mole of compound contains 2 sodium. We're going to put a 5 to balance that. Okay, so 10 and 5, and now sodium is fully balanced. Okay, sodium is fully balanced. And then check chlorine. Chlorine is also fully balanced. Okay, chlorine is fully balanced. Now let's check the right-hand side. Okay, right-hand side we have a sulfate here, we have a sulfate here, and we have a sulfate here. Okay, that's 2 moles, that's 1 mole, that's 5 mole. 2 plus 1 plus 5, and we get 8 moles. Okay, we get 8 moles. So when we have 8 moles of the sulfate, we need some sulfate on the right-hand side, on the left-hand side. So let's go back and look at the left-hand side. Left-hand side we have sulfuric acid. So we're going to write sulfuric acid. And we need to make sure we have exactly 8 moles of sulfuric acid. And then you just put 8 over here. Okay, you just put 8 over here. And then, so we can clearly see the left-hand side, 3 reactants were all used. Right-hand side, 5 product we used 4. And then the only thing we didn't use is water. So the final thing is copy water over. Okay, copy over, water over. You have, let's have a look at it. Okay, we have 16 moles of hydrogens and 8 moles of oxygen. Okay, so 16 moles of hydrogens and 8 moles of oxygen make exactly 8 moles of water. Right? This one here is 8 moles of water, and we're just going to put 8 over here. Okay, so now it's fully balanced 2, 8, 10, and 2, 5, 1, 5, 8. So this is a fully balanced equation.